consider this given problem statement. Let this mathematical expression, that is union of sets representation, it is represented here as T, where each x subscript I contains 10 elements and each y subscript I contains 5 elements. So if each of the element of set T is an element of exactly 20 of sets xi's and exactly 6 sets of yi's, then what is the value of n? That is what the requirement of the problem statement is. Now, before we dive into the problem solving part of this problem statement, first of all, we need to understand this given statement that is provided here, right? So here, first of all, I'll consider this t. For this t, we are having two different expression, one for y and the other representation for x, and all of these three are same. So what is the meaning of this? So this represents the union of 50 sets. The sets are named as x1, x2, x3, and all the way up to x50. So x1 union with x2, then union with x3, and so on all the way up to x50, because the limit starts from 1 and it goes all the way up to 50. Similarly, we can say the same for y as well, right? That is, t is also equal to the union of these sets, that represents here the union of y1, then again y1, y subscript 1, then y2, then union with y3, and so on all the way up to yn, because here the upper limit is given as yn. So this is what the representation is. Now, also, it is given in the problem statement that each xi contains 10 elements, right? So first of all, I'm going to consider this part. So each xi, x subscript I, contains 10 elements. That means the total number of elements present in this T with regard to this x subscript I can say here that the number of elements present in this set T according to this context, so this will be equal to 50, because there are 50 such set and each set contains 10 elements. So this will be equal to 500, right? Now we'll talk about the next part, that is for y, right? So for y, it is mentioned that each y subscript I contains 5 elements. So now we'll analyze this particular situation. So for this one, we can definitely say that the number of elements, the number of elements that will be present in y, right? So the number of elements present in this all union of y subscript I, so this will be equal to n, because total n number of sets are given because of this particular operation, and each set contains 5 elements, so that is nothing but 5n. So these are the data that we have extracted out from the given problem statement. Now if I talk about the next line, right? So if each element of set T is an element of exactly 20 of sets x subscript i's, so now I'll consider this problem statement, right? So based on this we can say that 20 times the cardinality of T, that is the number of elements present in T, this is equal to 500 according to the given problem statement. So from this the cardinality of T comes out to be 25, right? Now if I consider the set y subscript I, so now I'll consider this particular problem statement, that is exactly 6, right? So now again this part is also given to us, that exactly 6 sets, that is y subscript i's. So if I talk about this part, so we can say that each element of T appears in exactly 6 of the y subscript i's sets. So this is the number of sets. So from this again we can mention that 6 times the cardinality T, the cardinality of set T, that will be equal to 6 times 25. 25, that is nothing but 150. 25 is equal to 150. Yes. So thus we can say that this 5n which I have computed here, this is nothing but this is equal to 150, and from this value of n will be 30. So this is the final required answer. So the value of n will be 30 in that case. Okay. So I hope it is easy to understand and you understood the problem statement as well as the approach and the solution for this.